Hello and welcome back to the class. We are in the last section of visualizing data. We are going to go over some examples of visualizations created with packages that people have created to build on top of ggplot2. We are going to try to replicate or maybe even improve on some visualizations that are already out there. So I want to first talk about gghighlight. gghighlight is a relatively new addition to ggplot. In the previous section, I showed a way to surface important data while keeping the background data gray for context. This package simplifies it. There's also a link to their site with even more documentation, because this is going to be just an overview, not an overview, an introduction to a lot of these cool packages. So we'll use historical monthly average temperature data from the National Centers for Environmental Information. Alright, so you see this chart here that they've got. This is contiguous U.S. average temperature since the 1895, through the most recent year. We can do better. So let's start with importing the data, the monthly figures. I have it already on your system. Just go to Library Reader to bring it up, to bring in the package that will help you import the data. So let's create a new object called temps and read CSV, and it's in, let me see, where am I? So I need to make sure it points to more charts / data / okay, and that's that first one. It's 110 TAVG all 5 1895 to 2018.csv. Okay, I can ignore the warning. So I've got okay, I need to skip some rows because the data that they have is formatted. So I just need to pass this argument, comma, skip equals 4. Let's try it again. Much cleaner. So let's see. There's some lines in here if you have to deal with Lubridate, because we want to convert these into dates and months. So there's some code in here that are commented out because some people might have some issues installing Lubridate. Let's see if I get any problems. Yes, I have a problem because I don't know how to spell. Okay, let's library Lubridate. Okay, no issues. Great. So, I want to modify this by making sure, because if I take a look at the structure of temps, what do I get? It thinks it's an integer, the date, and everything else is all these are numbers, it considers it. But I want R to know that it's a date. So I need to do temps. I'll create a new variable called, actually I'll just paste it into itself. Date is, what is it? What is the format? It's year and month. But there is no year and month function. It can only recognize year, month, and dates. If you recall from the previous section in wrangling data, YM is not an option. So we need to turn this into year, month, and date. So how do we do that? We can paste an 01 at the end and make it think it's the first of the month. So to do that, I'm going to nest paste O in there. And this time it'll be temps date. And I'm going to add an 01 at the end. And I need to make sure I have one more parenthesis there to work. And let's see. And take a look at the structure of temps. It is a date. Good job. So there's two things we need to extract. One is the year, and one is the month. So let's extract the date, the year. Temps year is the function from lubridate. Temps date. Got the year now. Perfect. And let's get the month. Is month temps date, $ date. So that's numeric. And let's make sure that is recognized as a numeric and not a factor, just to double check. As that numeric, we're converting that. And now let's also create one for label, month label. So once again, month is the function, temps date, and this time the argument we're going to pass is label equals true. So temps is now, we've got month 1 and month label January. Not bad. Temperatures. Let's round these to 0 digits. Rounded. Value is round, temps value digits equals 0. Okay, and the last thing we're going to do is we're going to turn the year into a factor, because this will be easier to chart with later on. So because it was a string before, I'm going to turn it into a factor. Because it's a number, we need to turn it into a character before we can turn it into a factor. Do you remember in that first introduction way back when, where we talked about the issues when converting factors from numbers? It's because you remember, right? Year. Perfect. Everything seems to be retained. So now we can plot it. Let's take a look. ggplot, library ggplot 2. And I'm gonna do something different than what they kind of visualized. I want to layer it all. So temps is the data frame. AES is going to be X is going to be month, right? I want to layer it. Y is the value. Group equals year plus geom line. Let's just see how that looks, basically. That's a pretty thick chart. So let's style it up a bit. Scale continuous. Breaks will be because right now it's just 2.557. We want this to recognize that these are months. So we need to break it up by adding sequence of 1 through 12. Break it up by 1. Limits are, of course, 1 through 12. 1, 12. Plus theme minimal, because I like things minimalist. Minimal. Plus labels. Labs is y equals average temperature. Title is monthly temperatures since 1895. And caption is where we're going to source it. Source is NOAA. Run that. I need to specify what I'm going to make continuous, and that's the x-axis. Okay, not bad. So, Let's use the gghighlight package to make this clearer to readers. Okay, if you don't have gghighlight installed yet, then type in install.packages gghighlight in quotation marks. I'm going to say no, because I think I already have it. Great. So now library, gghighlight. No, I thought I had ggplot updated, so I'm going to quickly update. So maybe I can install this again. Okay, I should have ggplot 2 in there. Oh, that's weird. Delete you, old version. Load you, new version. That's weird. I've never seen that before. So, library gghighlight. Now it'll work, because it's loading in the latest version of ggplot 2. Yay. So, keeping my old code, reusing it, and this time I am going to add at the bottom gghighlight. And I'm going to pass these set of commands. Max of as.numeric year. So what I'm saying is highlight the largest values that are within year and the number of which max highlight equals max underscore highlight equals 4L. So that means I want to highlight the 4 most recent years, 4 highest years, max years in this data set. Wow, you see that? And you know what? Let's add color in there by year. Instead of group year, let's do color equals year. So it's a little bit more obvious. Okay, you see that? So now it's automatically labeled it and kind of separated it, and it connected it by color to this. So it's very clear here that the most recent years, it's been getting really warm. It's high up there out of all those years. It's encroaching up higher and higher on these recent years. Okay, maybe not 2018 yet, but toward the month, toward definitely in June, in fall and winter, it's getting up there. So this is a way to use highlight to really break out the important pieces of data. So if you like these labels, that is built on something called a package called ggRepel. So let's look at that. Library ggRepel. Let's see if that's loaded. Great. If you don't have it loaded, do install.packages ggRepel. Let's bring in that ages data set. It should be there. Yep, ages is clean that up. Code, more charts data, delete all this. It's now ages.csv. Get rid of that comma. Boom. Ages is now there. So I'm going to look at library dplyr, library string r as well, because I'm going to play with strings. I'm going to wrangle some data. So I want to just focus on all the Toms, all the data for the Toms, actors named Tom. So let's do it. Ages, filter, string detect with an actor, whether it has the name Tom in there. I've got 20 movies with toms in them. So now I can visualize this. ggplot toms AES x equals actor age, y equals actress age, color is actor, label equals movie, plus geom point because I'm making a scatter plot, plus theme minimal, plus gonna add some labels, actress age, x equals actor age, title equals Tom Hanks versus Tom Cruise ages, comma, caption, source the data, source is vulture.com/IMDb, plus, and now this is the function I'm passing from ggRepel, geom text. That's it. So let me run this without geom text real quick. Actually, geom text is not part of Repel. That's actually part of ggplot default. And as you can see, it plops the text right on top of the dot. So when people like Edward Tufte says it's impossible to programmatically create graphics like this, in that sense he's correct. But if we put in the library ggRepel and run that code again with this line of code called geomtext_repel instead of geomtext, this is what it looks like. And I need to fix my grid a bit. Okay. So you see the difference? It's no longer plopped there, it's kind of set aside. It's pushed so it doesn't collide with the other text. You can still adjust this, and there's some documentation linked to show you how, but it all depends on when it's first generated, you see. Okay, so that's slightly better. So it's not bad for one line of code. Alright, so we've gone over gghighlight, and we've gone over ggRepel, and we're going to go over just a couple more, just like a handful of more visualizations in this next chapter. So I'll see you in the next video.